Alright, let's evaluate the following limit. Limit as x approaches negative 4, 3x squared plus 11x minus 4 over x squared plus 3x minus 4. Now before we actually look at simplifying this rational expression any further, right, because we can notice here that the numerator and denominator here are both quadratic expressions. We want to test to see if this limit actually does produce a restriction, right? So specifically on rational expressions, that restriction is going to be on the denominator. So let's see if this actually creates a restriction. We know that the denominator cannot equal 0 because then the rational expression is going to be undefined. So I'm going to substitute x is equal to negative 4 into the denominator. So we basically get negative 4 squared plus 3 times negative 4 minus 4, and you can notice here that you get 16 minus 12 minus 4, which is in fact 0. So this limit will actually cause a restriction on the denominator, right? So therefore we have to simplify it, and how we're going to simplify this is we're going to factor both quadratic expressions on the numerator and denominator, right? So let's start with the numerator. So the numerator here is 3x squared plus 11x minus 4, so I want to factor this, right? So I'm going to factor out a quadratic. I'm going to write down the coefficients. A is equal to 3, B is equal to 11, and the constant C is equal to negative 4. Our rule here is to factor these guys, you want two numbers that add up to 11 that multiply to AC, right? Two numbers that add up to B that multiply to AC, and AC here is negative 12, right? So two numbers that multiply to negative 12 that add up to 11, you can basically do negative 1 and 12, right? I'm going to use these coefficients to replace the middle term, so we get 3x squared minus x plus 12x minus 4. I'm going to factor these two, I'm going to factor these two, so you get x 3x minus 1 plus 4 3x minus 1, and when the inner factors are the same, then you can just kind of group them together, factoring by grouping, so you get x plus 4 times 3x minus 1. Okay, so this is our numerator factor. Let's do the same thing for the denominator. Right, so we get x squared plus 3x minus 4. A here is 1, B here is 3, C here is negative 4, AC here is negative 4. Two numbers that multiply negative 4 that add up to 3. So we could basically do 4 and negative 1, right? So in this case you get x squared plus 4x minus x minus 4. I'm going to factor these guys out, this pair and this pair, and you get x times 4 minus 1 x plus 4, and then when the inner factors are the same, then we can factor by grouping. We get x minus 1 times x plus 4. Okay, so this is what the denominator looks like. Now I'm going to rewrite my limit, and I'm going to put in these factors. So now we have limit as x approaches negative 4. Right, for the numerator we had x plus 4, 3x minus 1, and for the denominator we had x minus 1, x plus 4. And now you can notice here that this x plus 4 was problematic, this factor on the denominator, because when you let x approach negative 4, we had a restriction on the denominator. But you can notice here that there is a common factor on the numerator and denominator, so we can cancel those out. And now, our issue is solved, and now we can just substitute. We can allow x is equal to negative 4. So if we do that, I'm going to plug in negative 4 wherever I see x. You get 3 times negative 4 minus 1, and negative 4 minus 1, right? So we get negative 12 minus 1, which is negative 13, and negative 4 minus 1, which is negative 5. The negatives cancel out, and we get 13 over 5. Okay, and that is the solution of our limit.